How can you hear? I haven't said anything yet, Lou. You hear me breathing or something? I'm out of breath here, huh? Okay, rushing to get ready. I wonder, Lou, if you've written some kind of script that just goes out there and sends that message every time somebody gets there. In which case, if this were a programming class, you'd probably get an A+. But since it's a math class, I guess that doesn't help any. All right. Well, somebody can hear me. I can see myself on the or text on the computer here, so it's going off across the web. I can see it on the screen. I can hear myself talking, so I'm assuming people in class can hear me. So I guess with that, we can go ahead and begin. And I guess I can close this document, which brings me back to here. And I can say that this is Thursday, December 10th, and this is Math 156. Okay. Got a few administrative odds and ends to take care of before we get into the area under the curve, which we were in the midst of last time. If you want to see me during my office hours today, which are 12:15 to 12:45, I'll be in North Hall 207. Okay? And I encourage you to come and do me a favor. What I mean by that is that's where they're having, math department's having its holiday potluck. So every minute I spend answering your question is a minute I'm not spending eating some food. So you would help me avoid my holiday issues. And, one might say that it's generous to call them holiday issues. They're probably 365-day-a-year issues, except for next year when there'll be 366-day issues. But anyway, enough of my personal revelation. The exam is in two parts. To be a total of 20 questions. I still haven't decided which parts are going to go which way. I'll tell you that in an email soon. The online part will be just like our things we've been having before, except that it'll be probably more than 10 questions. I think when the test was 10, the quiz was 5. Sometimes there was some variability there too. But it'll look just like those, and you'll have 2 attempts, and you'll get to see what you did on the first attempt. An online part, let me see when it starts. It starts on Tuesday, December, what is that, the 15th? I better check and make sure I got that right here. It's next Tuesday, and that is December 15th, right? Okay. At 7 a.m. and it ends on whatever day the exam is scheduled for, which, by the way, as long as I'm here, if we go out to our OneDrive, OneDrive, there you go. There's a file out there that has my office hours for exam week, which is right here, the first file. But it also has when the exam is. And the exam is Monday, December 21st. I'll get back to this in just a minute. Monday, December 21st. Okay, so ends on Monday, December 21st at 11 p.m. And you're certainly welcome to take it up to the last minute. My estimate is there probably won't be too many people hanging around 21st of December at 11 p.m., but you have that much time if you wish. Okay, so that's when the online part of the exam starts and ends. Okay, and the office hours for exam week. Okay, here it is. Next Wednesday, I'll be here from 8 to 10 a.m. in North Hall 214E, which is my office. Okay. Thursday, December 17th, I'll be in that same place from 10 to 12:30. Okay. And then after that, I have an exam in North Hall 205. And the last thing is our exam on Monday 21st. But online office hours are available by appointment. And so if you just email me or catch me in the hall somehow or something, just contact me in whatever ways you see fit. I'm sure we can set up something where we can meet online. Met with one student happened to be over Skype, but if you don't have Skype, we can do it over Google Hangouts, which, by the way, if you've been viewing the online recordings, the actual classes, they've been streamed through Google Hangouts, so it won't be too different from what you've been doing, I don't think, there. And okay, so that's that. Any questions about that so far? Okay. Let's see, that's that. Office hours for exam week, okay. Quiz 5 ends this coming Monday at 11 p.m. and there will be a video available starting Tuesday morning to go over that. Okay. Test 2 ended last night, and we're going to go over that today, but I want to go over this new material first, and if by some chance that takes too long, I'll make a video for Quiz 5 and put that out there too. Okay. But I do want to be sure we do the new material first, which is the area under the curve. Oh, one more thing. As you may know, there is an online survey process, and I would really appreciate if you would take that survey. Okay. Appreciate what feedback you want to give me. I want to emphasize to you, not only is it personally confidential, I have no idea who does things, but I don't even see the results until after the deadline for turning grades in. So just in case somebody, like perhaps me sitting out there, would say, I'm afraid to say something bad because they'll get mad at the whole class and give us a bad grade. Well, I won't see what you said until I've turned my grades in. And to change them after that, I got to submit a form. And so if the registrar saw that Dr. Caldwell was submitting 30 forms lowering everybody's grade, I think it'd be a little suspicious. So I think you're relatively safe to say whatever you want to say, because I won't know about it until then. I'll never know you personally, and I can't take it on the whole class. Now, I might nail next semester. No, I'm just kidding. Just kidding, Dean. Actually, this is your chance to help people next semester, and by suggesting things that can be done better here, and by just rating how well things have been done. Okay, so where were we last time? Glad you asked. How can we find out? Well, we can go to our favorite place, I guess our second favorite place. Favorite place being D2L, to the OneDrive. Let's go to the OneDrive. And we were working in Snap, so we need to look at one of our Snap links here. And we were working December, whatever, the 8th, I guess it was. We'd done the area under 1 and the area under f of x equal x. We're working on the area under f of x equal x squared. And actually, we come up with 2 estimates for that area. And our process was, well, we got this, oh, when it comes up, we can talk about it in a minute. We've got this curved area we're trying to find. And if you're like me, when I started calculus, I had no idea how to find a curved area. But people do have a good idea how to find areas of rectangles. So standard process in math, and again, my guess is other sciences too, when you got something new, try to relate it to something you already know. And so we said, okay, well, we could draw a rectangle over the whole thing, and that would be some estimate. The interval we're working on right now is the interval from 0 to 10, so that's 10 long. This is the function f of x equal x squared, and we're out here at the end is at 10, and 10 squared is 100. So we've got 100 up here and 10 across here, and multiply those together, we get 1,000. Okay. All right. Well, that's better than throwing up your hands and saying I have absolutely no idea. Oh, and then we said, well, if one rectangle worked good, maybe 2 is better. So we said, let's split the interval in half. So this is from 0 to 5, and we'll go up to the curve here and come across. That's the red one, and then we'll go here and come up here too. It's just we'll be using the second estimate a little bit less. And we did that, and we said, well, this is 5 long. We're at the curve. Curve is x squared. This is 5 squared at 25 here. So this is 5 times 25. And remember, the scales are different here. That's why the line that's 5 looks a lot longer than the line that's 25. But anyway, 5 times 25 is 125. So the first area is 125. The second one is still 5 long or wide, but it's 10 high. 5 times 10 is 500. And if you add those together, you will get 625. So we've come down quite a bit. And here's how we did it. The area above uses one rectangle. Let's try two. And we did. And let me move this over a little second here. Give ourselves a little more room. Okay. And so for the first one, first of our two, we said get to the point 50, which is right here. Okay. And set the width to be 5. Set the height to be the value of the curve at 5, which is 5 squared or 25. Okay. And make a rectangle, which we did, and it spit out to us the area of that rectangle too. And they said, let's do it again. Let's go over here now. We're going to go to 10. So get to the point 10, 0. Set the width to be 5, still 5 here. Okay. What's the height? Well, what's the curve over 10? It's 10 squared or 100. Get a rectangle, and that gave us the second one. So now our estimate is 125 plus 50 equals 625. Okay, now we're going to do, let's do 4 or 5, or as I said, even 100 or 1,000. But I don't want to sit here and piece together 1,000 of these things. So let's try to get them into a repeat. So I'm going to copy this, or duplicate is the word Snap uses, and put it down here. I'm sure they put a lot of thought into duplicate rather than copy. It'd be interesting for me to know. I like to know. I'm going to delete this duplicate here. What their thinking was on that. Well, I duplicate you better, but they had a good reason. Okay, so some things that went on here were I did a lot in my head, and it wasn't too bad. But one thing I did was I said, well, we're at 5 here, and the function is the squaring function. So 5 times 5 is 25. We need to get a formula so we can just do that over and over again. And it would be nice to do that. We're going to have to say something like x squared. So we need a variable, and actually we've got one called x left over from before. So let me grab my x here, and here's an x here. Of course, it won't do me any good if I don't set its values and everything. So I'll grab myself a set statement here, and I'm going to probably need a change statement too along the way. If I don't, I'll throw it later. Okay. So what we're doing here, and I'll put a comment here, and before I get too far, let me save this with a different name. File, save as, December 10th. And I'm going to be very optimistic and not put any qualifier. We're going to finish this today. Better, it's our last day, right? Okay. So rather than continue or more on it, we're going to do it. Okay, so we're going to, what we do here is make it easy to use repeat. That's what we're doing here. Okay, so so let's do that. In fact, let's go ahead and make that variable here. Here's our set. So we're at 5 here, so I'm going to set x equal to, here's x up here, to 5. Okay. And now when I go to get my height here, I got that by squaring 5, but I'm going to square x now. So all I have to do is keep changing the value of x, and then I'll get my different things squared. Okay. So I'm going to use my x, which will have the value 5 here. Okay. But I need my function, and by grabbing my function, I could write x times x or x squared. But if I use my function here rather than do that, then when in 5 minutes later I want to look at the area under x cubed, all I have to do is change my function. So the only way I got 25 here was by squaring 5, and this will do exactly the same thing if I've executed that block. Let me separate it just for a minute to show you. X is now 5. So now if I do this, I should get 25. There's my 25. All right, so I'm going to put that in here now. So we're making this a little more amenable to doing over and over again. Okay. So, so that looks good. Now, what would it look like for the second one? Well, if we get to the point 10, and we'd have f of 10. But if we do our x right, x will be 10. Okay. In fact, we should do that right now. We shouldn't keep saying get to 5. We should say get to x. So we have to keep putting we're trying to get all the numbers out of here if we can. Okay. Okay. Now, the width being 5 is a little different. Okay. We got that width by taking the whole interval 10 and divided it by 2. We said we're going to do 2. So let me duplicate this block, or rather still, let me take the one that we know works for the second point and put it in the same format here and see if we can see a pattern here. Okay, so we're going to do this one the same way as this one and see if we can come up with a pattern. All right, well, we need our set x, so where's our set? That's down here. We'll hang on to that. There we go. Set x equal to 10. Okay, now x is 10, so we can put the x there. We want to make this block look almost exactly like this block. And that way, the repeat, we can just do them over and over again without having to have a different one. So set x equal to 10, that's good. Width is still 5. Both of them have width 5. Okay, in fact, we're going to do our rectangles so that they all have the same width. If we take 100 of them, we'll take this interval and divide it by 100 so they all have the same width. In fact, let's go ahead and take that out of the equation here. You absolutely do not have to make your width the same in all your rectangles, but it's not a bad idea. So we only need one of these. And before we ever get started, we're going to set our width to be 5. So in all of these, it never changes, so they'll all have width 5. All right, and we'll just trying to do, it looks like it's got a red circle. It's trying to do something here. I'm going to stop it. Okay. All right. So now how different are these guys? Let's see. Oh, yeah, we still haven't got our, the reason we got our 100 was we were at 10 and we squared 10. Okay, but x is now 10, so all we have to do is put an f of x right here. I'm going to duplicate that. Put it over here for just a minute, just make sure that's right. I don't want to do all those things, so I'm going to separate them. Set x equal to 10. So x is now 10. We aren't seeing x. I probably should show it to us over here. This is just for development purposes. There's 10. If I get this, I should get 10 squared or 100. Okay, so that's fine. Okay. And now I can take this 100 and put it right on top of there. Okay, so the goal again, get these guys looking exactly alike, so we can just put them in a repeat. And they're looking pretty good, except for this set equal to 5 and set equal to 10. Now, I don't know how long it might take somebody to think of this, but as we're going through here, we start at 0, we go 5, we go another 5. If we divide this thing so that we had, I thought I turned that off, but I guess I didn't. Sorry about that. That was a media response, I guess, or something, rather than a ring. Okay, anyway, if we have 100 rectangles, each, we could do 100, but let me do 5 of them just a minute, because it's easier. The whole length is 10. So if we have 5 of them, it'll be 2, 4, 6, 8, 10. So each time we're going to be adding on whatever the width of the first rectangle, which is the width of all the rectangles. So instead of us set x equal to 5, we'll start x out at 0 because we're doing the interval from 0, and we'll change x by 5, or by the, so change x. I think I put a change up here somewhere when I first came over. Here it is. Okay. So if I start x at 0 and I change it by 5, sure enough, it'll be 5. In fact, I don't want to draw that rectangle. In fact, I don't want to do any of that stuff. I want to show you that the function will be that way. So here I'll set the width. All right, x is 0. If I change x by 5, what is this? Oh, I somehow lost my x in there. Well, I probably dragged it over with nothing in there. All right, change x, started at 0. There it is, 0. Change it by 5, and there it is. If I take this one and get rid of making it 10 and put another change it by 5, then when I click it, 5 plus 5 is 10, so it'll be 10. So now, if I put this back together again, these two blocks look pretty close to exactly the same to me. You do have to start at 0, change it by 5, go to that point, set the height to be the value of the function at that point, draw your rectangle. And those two are the same. So we can put them in a loop, a repeat. Now, the scripts for 5 and 10 are the same. So we can repeat. So let's do that. Let's go to the control here and get our repeat block, which is a little bit off the screen, I guess. There it is. Repeat, and we're only doing 2 right now. And I'll just duplicate one of them because they're both the same and put it in there. Now I still have to get myself set up right, because if I ever do this over again, I don't want x to be out there at 10 or wherever it might be. So I'll duplicate that. Come down here. We might eventually put all those together. I'm going to keep them separate for just a minute. By all those, I mean the setup here and the thing. There's my setup. Okay. Now I've got these two pretty rectangles here. I claim if I change the pen to green and click this, it should do exactly the same thing, and all the red should go away. So I'll go over here to pen, get myself a pen color. I'll put it over here. Okay. Make it green or something that's not red. And now it's red. All right. And I tell you what I'll do. One more thing, just to slow things down a little bit and give us a chance to see what's going on here. I'm going to tell Snap to tell us what the value of x is. So that's over here to looks, and I'll have it say, okay, right after you change x, you tell me what it is. So I'll go over here and grab myself an x. And if I talk fast enough, well, I can always hit the pause too. 2 seconds will give me, even my slow reflexes, a chance to get to the pause. We can talk about as long as we want to. Okay. So we're going to set the width to 5 and start x out at 0. And in fact, let's get to 0 just so we can see it there. Get to the point. And I could put a 0 in there, but just in case I ever want to start somewhere else. All right. So this is my setup. My width is 5. Sure enough, my x is 0, and there it is. So now if I do this, one time through, it should change x by 5. Well, it's a 0 right now, so it should go right here to 5. It should tell us that. Well, actually, it'll make it 5. Tell you what, let's let it tell us after it's gotten there. So the say is just there for our convenience. We can put it where we want to. Tell you what, the moment of truth is when it draws the rectangle. So let's let it do everything right before it draws the rectangle. So what's it going to do? X is 0. It's going to change it by 5 and get 5. It's going to go out to that point. It's going to say, oh, f of 5 is 5 squared or 25, so the height should become 25. And then it'll tell us that, and then finally it'll draw the rectangle. And it'll go back and do it again. All right, so let's maybe start out okay. We're going to hit this. I'm going to pause it for a minute. Okay. So sure enough, it got out to 5. It told us the 5 here, but we can also see it in the x is 5 here, and the height is 25. And if I let it go, the next thing it's going to do is draw that rectangle and go back and change things again. So I'll let it go. Now I'm going to pause it while it's at 10. So sure enough, it wiped out the red rectangle with a green one. Okay, that was right here. It came back around and said, I'm going to change x by 5. Okay, if you're at 5 and change it by 5, you're at 10. Sure enough, it's sitting out here at 10. It got to that point. The height should have been 10 squared. There it is, 100. And it's all ready to draw this rectangle. So I'll let it do it. So sure enough, it drew the two rectangles again, but it did it with a repeat. Okay, so now we're ready to make the thing anything we want it to be. Well, we're almost ready. We got to do one or two more things. Actually, one more thing here. If we only wanted to do 10, we're done. But how do we get this width? We got the width by saying the whole interval we're looking at is 10. I just picked 10 to start with. Got to do something. And I said we're doing 2 rectangles. Okay, so 10 divided by 2 that's 5. So in fact, let me just, for emphasis, put this in here. That's where the 10 came from. So we got a division operator, and we'll replace this 5 as 10 by 2. Okay. But we don't always want to do the interval 10, and we don't always want to have just 2 rectangles. Okay, fine. Well, in that case, let's pick up some variables to take care of those 2 things. Let's call the 10 length of interval. Because I want to do different lengths for one reason. I don't know. I happen to enjoy doing this, but if I had to calculate a whole bunch of intervals over a day or 2, I wouldn't want to do it all over and over again. I want to be able to do this and just tell it what my interval was. So, okay, so length of interval. So we'll click OK. Now we have a variable called length of interval. And we also need to have how many rectangles do you want? So we'll make a variable called number of rectangles. All right, so we got those 2 new variables here. And the one thing nice about long names is it makes it easier to remember what they are, but it kind of messes up your screen here. Let's see if we can maybe squeeze things out. All right, so we'll do that in a minute. So before we get started then, we need to, here's our pen, set those two variables. So where's our set? Here's our set. All right, there it is. We're going to join them on in just a minute, but let me. Length of interval, we'll set that to be 10. And then we've got number of rectangles, so we need another set for that. Right now we've got 2 rectangles, so we'll set there. Okay, and when it comes time to divide, we don't want to divide by 10 by 2 directly. We want to divide by the length of the interval by the number of rectangles. Here's the length of interval, so put that right in there in place of the 10 and number of rectangles. Of course, it's the same thing, but when we change the variable, we don't have to keep doing that calculation ourselves. Okay, now, why are we repeating this twice? Because we have 2 rectangles. So we really want to repeat by the number of rectangles. Okay. All right. And let me get this say out of here now. That was nice when we were understanding it. Okay. Okay, well, there's one more thing in there. Change x by 5. And the reason we changed it by 5 was it's always going the width of the rectangles are going to be. So that 5 really is the width of the rectangles. So we have to change it by the width. Here's width right here. There we go. And so now we should be in business. A couple of new variables, length of interval. We're making it 10 to start with because we want to see if we get the same answer, 625, before we go on to something else. And see we draw the same rectangles. I'll change the color right now to yellow, let's say. All right, so when we get through, these 2 green rectangles should all be yellow. We did it right. Okay, so our width is we have our length of interval is 10. We have 2 rectangles. So the width is going to be 10 divided by 2, which is 5. We're starting x out at 0. Because we're always doing right now 0 to something. And we're going to go to our point, which is x is 0. Okay. And then we're going to repeat twice. We're going to change x by the width, which is 5, one time. Go to that point, 5, 0, 10, 0, whatever it may be. Set the height to be the value of the function at the right end. Get the rectangle, which will draw it and also tell us the area of this rectangle. Okay. And then go back and do it again. All right, so let's do our sets. Okay, so these guys are 10 and 2. Okay. I'm going to get them off the screen now, just so we can see what's going on here. They're set. And now we'll set the width to be 10 divided by 2 and x to be 0 and go back here. So there we are. Sure enough, the width is 5, and we're sitting here at 0, 0. Okay. And that's where we are. So now if I hit this, we should draw the same 2 rectangles. Let's see if we do. Okay. And we did. And we got, you probably didn't, if you saw pretty fast, the 125 flew pretty fast. 125 for the first one and 500 for the second one. There's one last thing to do. I don't want to sit there and read off all those numbers. In this case, it was 125 and 500, and add them up in my head. So let's make one last variable, which is the whole goal anyway, which is to get the estimate of the area. Well, let's put a variable in there and then put the things in to calculate it. Okay. So we need one last variable. Make a variable. Estimate of area. Okay. That's a pretty important one. That's the bottom line of the whole thing. Okay. And we might do this over and over again. So when you do, it's a good idea to start that off at 0 to start with. So let's do that. Where's our set statement? So we'll set the estimate of the area to be equal to 0 when we start. All right, and could put that different places, but here's a good place. Okay. So pick your interval, pick how many rectangles you want to use, set your estimate to 0, and now every time you draw a rectangle, remember the rectangle calculates its area for us in this variable right here. We want to kick this number into the pot. That is, we want to change our estimate of area by the area of this rectangle. And that's what I've been doing in my head as I go along. I said, okay, the first rectangle is 125, so we're going to throw 125 in there. And the second area is 500, so we're going to throw 500 in them, and we've already got 125, so we're going to get 625. Okay, we got a lot invested in this. Let me save it. Okay. All right. So let's, we can probably bring these together. Yeah, let's do that. So have to remember how many things to click. This just sets everything up for us. Here we are here, and we want to wipe out the yellow rectangle, so let's make it back to red again. And the red one should be gone when we do it. And the only thing different between this time and last time is that instead of me adding in my head, estimate of area should say 625. And it didn't. Yes, it did. It just took a second for it to do it. Okay. All right, there it is. There's a 625. Now we're in business. All right. Why don't we keep track here for a minute of some of our estimates here. Microsoft Office. I don't want to do Word. I want to do it in Excel. Okay, so this we're going to try to estimate area under f of x equal x squared from 0 to x. All right. Maybe make that a little bit bigger. All right. All right. What we're going to do is we're going to do it for a different number of rectangles. And then we're going to put the actual estimate that we get. We've already done a couple of these. We did one rectangle, and we got an estimate of 1,000. we did 2 rectangles, and we got an estimate of 625. Okay. Let's get bold here. Let's try 5 rectangles. All right. To do that, all we have to do, the interval isn't changing, is 0 to 10. Let me say that. Or x equal 10. We're going to start with 10. All right, so 10, 5. Clear our estimate out to 0 because we don't want that 625 to get these things added onto it, which they would do in our change by if we did it. So make back 0 again. Calculate your width. That's going to be different now because you still got 10 here, but you got 5 rectangles, so each one's going to be 2. Okay. And go to 0. Start with your starting point and get to that point. So let's do that. Okay. And now we're there. Let's just go through and do this 5 times. There are 5 rectangles, and we're getting closer, aren't we? Aren't you glad you didn't tweet that I was doing such an awful job? Getting closer. How close are we? 440. All right. All right. Let's do 10 rectangles. Number of rectangles is 10. And it's going to get a little messy here, so why don't we clear things out. And put the curve back. All right. So here we are. In fact, I tell you what, I'll probably still need that. Okay. All right. Number of rectangles. Did I put 10 in there? I've forgotten. We didn't do 10 yet. Okay. All right. So just in case I mess things up, let's do our reset again here. And here's our 10. All right. 10 rectangles. Looks pretty good. And we got an estimate of 385. The numbers are getting smaller, and you also can see that the overshoot here, we're getting closer and closer. All right, let's jump to the chase and let's do 100. See what we get. Okay, and we'll make them red again. So there are 100 rectangles, and that poor sprite is just working itself to fingers to the bone. 338, let's say we got. And let's do 1,000 this time. To make that roll a little smaller. So flip back over, and we'll make the pen green. And for 1,000 rectangles. It's working and working and working. Well, I forgot this actually set it green, so it's still red, but that's okay. It's the calculations. You can see it's really getting down there pretty close to it. Will it get you back from Mars? Is it that accurate? Maybe not. But if we aren't drawing the picture, we could ask for this thing to be millions. Now, there are definitely people have learned other ways to find the area, but some functions are so complicated that the only way to do them is to estimate with things like this. Now, there are different estimates, different shapes. You don't have to use rectangles. They're good ones to start with. It turns out other ones will get you faster. But this is the idea of it. It works. It's cleaning up its garbage. Okay, so for 1,000 rectangles, it tells us the answer is approximately 333.8. So let's make it 334. Okay. Well, that's nice. But is there some kind of pattern that might take us from 10 to 334? So what is there a pattern? Okay. Length, estimate of area. Let's try a couple of them. Let's try interval of length, say 2, and then we'll do 5 maybe, and then we'll do 10. Okay. We already did 10. Our estimate is 334. Let's do a interval length 2. And so here's the length. I'm going to say this now. And that's the one I'll put out to D2L. We did for 10 because that's the one we worked on some, not D2L, but the OneDrive. Okay. All right, interval of 2 now. And let's do it clear. Horizontal set size. All right. I'm down here and set things up. Okay. Notice the width of interval is pretty small. There's only 2 to start with. And let's find out what our estimate is going to be. So it's only going out to 2 now. I'm not going out to 10. Again, the poor little guy's just working so hard. And of course, if you're doing this, not just trying to understand, you wouldn't be drawing a picture. You'd just be doing the calculations. And it's still working, and we still see the little halo around here. And the halo seems to be gone now, so it must be done. You know what we should do? Well, it's not done, is it? Or did I click make a start again? I might have clicked make a start again. All right, I really messed this up now. Here we go. What I was trying to do was make it tell it for sure when it was done. So let me do that. And when it's all finished outside the loop there, let's let it say done. All right, so back to the drawing board here, clear things out, draw the curve. Reset everything, clear it out. And now do it. When you're done, tell us, so I don't have to guess here by looking to see if the halo is around the graph there. We can also keep track here if you want to. We have to go out to x equal 2, so we're at x at 1.09 now, so we still got some more to go. The last value of x should be 2. 1.2, 1.3. We're getting there. 1.6. Are we there yet? Not quite. 8, 1.8. Done. It says done right here. And the estimate is 2.67. Okay. All right, let's try the area for 5, and then we'll see if we can guess the pattern. So the length of the interval now should be 5. Okay. And let's make the pen green. Okay. So we'll set up. And just make sure I just hit that button. Okay, and now we'll do it. We gotta wait till x gets out to 5. It's gonna take a little while, of course, but we'll get there. And then we'll see about the pattern. Uh-oh. I forgot to take off the word done, so it's saying done every time. Done's moving with it. Actually, it isn't saying it. The done is still there. I should have made it say done for 5 seconds and then it gone away. So we'll have to watch instead until when x gets to 5, and then we'll know we're done. Tell you what, I'm going to stop this because that's what's really slowing it down. So we'll tell it to say, okay. If you tell it to say nothing, not only is it blank there, but it goes away, so we'll say nothing. Actually, it did already, I think. And we'll restart and reset things up, rather. Now we'll do it over again. It should go a lot faster because it won't keep saying done every time we move it. See, it's already out to 2.3, actually. And it should go about halfway because the max out here is 10. It should wipe out our at 2 because we only went to 2. And moving a lot faster now. Up to 1.5. Up to 2. Okay, getting there, getting there. Just cleaning up this workspace. We're at 2.8. We're over halfway. Already to 3. Buzzing right along here. 3.8. All right. .7, 4.8. Almost see it in the horizon there. Now it says done, and we're done. And our estimate is 41.7. Okay, we're looking for a formula that will take us from 2 to this, from 5 to that, and 10 to that. Everybody see what that is? Well, I wouldn't if I hadn't been down the road before. But how might you get that? Well, we've got some information out there we've been working on. We have one, yeah, here we go. We started this. Let's see what we've got here. Files from class. Start the area under the curve. Okay, there it is. We did it for 1 and we did it for x because this was a rectangle, this was a triangle. Now we're trying to figure out what could this formula possibly be. Well, if you go back out there for a minute, look what happened when we did our slopes. Let me make this a little bit bigger. This is back what we did before we found derivatives and things like that. What we found out was that, just because it's easier to see with the 2, when you had the slope of x squared, the 2 became a coefficient and the exponent went down by 1. When you hit x cubed, the 3 became a coefficient and x went down by 1 also again. So the exponent becomes a coefficient, or you say you multiply by the exponent and you decrease it by 1. Well, that's not what we have here. But what do we have here? Okay, here it's like x to the first power. Okay. Now the exponent's gone up by 1. So the exponent's going up by 1, and now instead of multiplying by the old exponent, we're dividing by it. So if we wanted to guess what we might have here, here's our exponent. And this is a leap, absolutely. That's the way you make progress, by leaping and then checking it out. So the rule starting here, and I'll grant you it's not a lot. Raise the exponent by 1, and well, it's capitalizing this whole thing, but we'll fix that in just a minute. And then divide by the new exponent. And I'll put a bunch of question marks here. That's a wild guess, but that's what that pattern makes the first 2 right. This is x to the 0. So if you raise, you get x to the first, and divide by 1. Okay. So, well, it's easy to check to see whether it works for these. It should be x cubed divided by 3. That's what we're guessing. So we go over to Excel. So now we're going to guess x cubed divided by 3. So equals, here's x, you're holding your breath, raise it to the 3rd power, and divide it by 3. Oh my goodness, look at that. It's right on the money. 2.67, that rounds up 2.67. Let's divide it, let's drag it down and see what happens. 41.66666. Now this one's a little bit more off than the other, not much. It's a bigger area. It's an estimate. Okay. So, oh my goodness, it looks like that's what it is. All right. So sure enough, it turns out that that's the pattern for finding the areas. Now, let's go back out here for a second. Let's look at this one for a minute. This is a game that I might have been playing a long time ago. Pick a function, find its slope function. We know how to do that. Find the area under the slope function, okay, and see what you get. For example, take the function x. The slope is 1. What's the area under the slope function? We just found that one over here in the area under the slope function is x. So we got back to the same function we started with. You took a function x, its slope was 1, the area under 1 was back to x. Well, how could that happen? Could it ever happen again? Take the function x squared. Let me make this a little bit bigger just in case somebody's having trouble seeing it. Take the area, okay, take the function, we do, here, x squared. Take x squared. We know what the slope of that is, 2x, okay? The area under the slope function, we found that already. That was x squared under 2. Let's go back and look at that for a minute. All right, so we're going to do now. Take the function x squared. The slope is 2x. What's the area under 2x? Well, whatever it is 2 times the area under x. Okay. You make the function twice as big, the area doubles. So we've got 2 times, what was it? And this is what we did from the triangle. So it's x squared over 2. 2 times x squared over 2, and you're right back to x squared again. So if you start with x squared, go to its slope, take the slope and come back to the area, you get back where you did it again. And what turns out to be that for almost every everyday function you meet, and more than that, most functions that come up in everyday life, if you take the function and find its slope and find the area under the slope, you'll be right back where you started from. In this case, we did slope first and did area. If you do it the other way, if you do area first and then slope, you'll still get back where you start from again. Okay. So these facts are what's called the fundamental theorem of calculus. What they say is, for many functions, if you start with a function, find its slope, and then find the area under the slope function, you'll get right back where you started from. So here's x. The slope is 1. The area under 1 is x. Here's x squared. The slope is 2x. The area under 2x is x squared, so you're right back again at x cubed. The slope is 3x squared, and you take the area under 3x squared, which is 3 times the area under x squared, and you're back again. So that's what's called the fundamental theorem of calculus. But you can go it either way. If you say it in a more mathematical form, if we start with a function, call it f, and find the area under the graph of that function, call it capital F. Okay, so we've gone from a function to its area, and we're saying what's the slope of the area? The slope of the area, which is f prime, capital F prime, is back where you started from again. Okay, so that's the fundamental theorem of calculus. All right, so we just have a few minutes left, but let's see what we can do for quiz 4. Test 2 out, whatever ended yesterday was quiz 4. Quizzes, test 2. Let me modify that so that it gives us the answers, submission views. Show the answers to. All right. Now let's take a look at it. All right, question 1. Improving the product rule for derivatives, we encountered the following expression. It was f times g. Here was g at x2. This was f of x2 minus f of x1 over x2 minus x1. What is the limit of this expression as x2 approaches x1? Okay. Well, g is a nice smooth function. It's got a derivative. All this first thing it says is we're taking the value of g at x2. But as x2 gets close to x1, g at x2 gets close to g at x1. So this just becomes g of x1. The second thing here is exactly change in y over change in x for f. And that's what we use to estimate the derivative of f at x1. And the product rule says you start with two functions to have a derivative. So this whole difference thing here is just f prime and wherever we're going. Well, where are we going? We're going to x1. So the second part is f prime at x1. So it should be g at x1 times f prime at x1. And that is right there. All right, so we'll save that one. And what's the second question? We're going to estimate the slope of a function, and the function is 2 to the x. At the point where x is 4, we need to know the change in the value of the function as we go from 4 to a nearby point. We're going to do change in y over change in x. We choose 4.001 as the nearby point. So which of the following is the change in the value of the function as we go from 4 to our nearby point? Well, it's just the difference in the function at the nearby point, which is this, 4.001, minus the function at our starting point, which is x. So it's right, in fact, it's this one right here. The function is 2 to the x, so it's 2 to the 4.001, that's the value at the nearby point. And we want the change, so we have to subtract the value at the starting point. All right, let's look at question 3. when we looked at the function 2 to the x, we found that no matter what x we tried, when we found the slope of f at x, or at least the estimate of it, we divided it by the value at f, we always got the same number, or pretty close to it, about 0.693. When we did the same process with 3 to the x, we got a same different number, about 1.009. I'm sorry, 1.099. So then we started the search for a number with a special property. Which was that property? Well, we said, as nice as it is that the ratio is always some fixed number here and here, it'd be great if that fixed number was 1, because that meant the ratio would always be 1, or in other words, the slope would be the same as the function. Okay. So we're looking for some number where this ratio wasn't 0.69 and it wasn't 1.09, it was 1. And we said a reasonable thing to do is to try something between 2 and 3. If 2 as the base gave you something less than 1, and 3 as the base gave you something bigger than 1, then maybe something in the middle would give you something that's equal to 1. And that was what we picked here. The answer we get is always 1. Okay. Okay, I can see we're not going to have time to finish, so I will make a video with the last 4 questions on here and put it out on D2L. So I'll go over the last 4 questions in that video. If I have enough time, maybe I'll just let you do some one-stop shopping. Yeah, I will. I'll just do the whole thing. Okay. All right. So that's all I have, unless I have any questions or anything. Okay.